Hi, math enthusiasts. I would like to invite you to join us and be a member of e-DEOlogy community. If you become a member, you will help e-DEOlogy YouTube channel to make more math videos and to ease logistics expenses. See you all in e-DEOlogy community and get this beautiful e-DEOlogy fun badge and be a member according to your interest as a bronze member, a silver member, or a gold member. We love to see you in e-DEOlogy community. Hi everyone. Today we're going to study system of linear equations. Particularly, we will determine whether an ordered pair is a solution. Let us have some introduction. A linear equation in two variables, such as 2x plus y equals 5, has an infinite number of solutions. Each graph is a line. Remember, every point on the line is a solution to the equation, and every solution to the equation is a point on the line. Let us determine whether an ordered pair is a solution. When two or more linear equations are grouped together, they form a system of linear equations. To solve a system of two linear equations, we want to find the values of the variables that are solutions to both equations. In other words, we are looking for the ordered pairs xy that make both equations true. These are called the solutions of a system of equations. To determine if an ordered pair is a solution to a system of two equations, we substitute the values of the ordered pair into each equation. If the ordered pair makes both equations true, then it is a solution to the system. Let us have example 1. Determine whether the ordered pair -2, -1 is a solution to the system. The first equation, x minus y equals -1. Second equation is 2x minus y equals -5. To determine if the ordered pair -2, -1 is a solution, we substitute it into each equation. If the ordered pair -2, -1 makes both equations true, then it is a solution to the system. Let's take the first equation, the x minus y equals negative 1. Let us now substitute the ordered pair respectively, the negative 2 to the x and the negative 1 to the y. So we have now negative 2 minus a negative 1 equals negative 1. Let us simplify. We can remove the grouping symbol. So this negative 2 will come out as negative 2. And in here, the negative sign and the negative sign becomes positive. So this becomes positive 1 equals, the right side is still negative 1. Simplifying the left side, the negative 2 plus 1 is now negative 1. And we can see that this is equal to the negative 1 on the right side. So the ordered pair makes the first equation true. Let's take the second equation. 2x minus y equals negative 5. Substituting the values respectively, we have now 2 times x becomes negative 2, then minus y is now negative 1, and the right side is negative 5. Simplifying further, 2 times negative 2 will be negative 4. This negative sign and the negative 1 here becomes positive 1, and this is equal to negative 5. Simplifying the left side, negative 4 plus 1 is negative 3, which is not equal to negative 5. So it means the ordered pair negative 2 and negative 1 makes the equation 2 false. So it means to say this ordered pair negative 2, negative 1 is not a solution to the system of linear equations. This is our final answer. Let us have example 2. Determine whether the ordered pair negative 4, negative 3 is a solution to the system. And this is the same system of equations from our example 1. So what we're going to do is to substitute this ordered pair negative 4 and negative 3 into each equation. If the ordered pair makes both equations true, then it is a solution to the system. Let's take the first equation, x minus y equals negative 1. Let us substitute the ordered pair negative 4 and negative 3 respectively. We know that the first number negative 4 is for the x and the second number negative 3 is for the y. So we have here negative 4 minus a negative 3 must be equal to negative 1. Let us simplify the left side. This negative 4 will simply come out as negative 4. The negative and the negative becomes positive. So this is now plus 3 must be equal to negative 1. Simplifying our left side, so we have negative 4 plus 3 is equal to negative 1. And we can see that this value is equal to the right side value, which is also negative 1. So the ordered pair negative 4, negative 3 makes equation 1 true. Let's proceed with equation 2. The 2x minus y equals negative 5. Let us substitute the ordered pair negative 4, negative 3 respectively. So we have now 2 times the x, which is now negative 4, then minus the y, which is now negative 3. And this must be equal to negative 5. Simplifying the left side, 2 times negative 4 is negative 8. And this negative and negative becomes positive. So this is now positive 3 equals negative 5. Simplifying this negative 8 plus 3, we have negative 5, and is now equal to our right side value, which is also negative 5. So this ordered pair negative 4, negative 3 makes equation 2 true. It means to say the ordered pair negative 4, negative 3 is a solution to the system of linear equations. This is our final answer. Hi everyone. Today we're going to study system of linear equations. And we are going to solve this by substitution. Given a system of two linear equations, here are the steps in solution by substitution. Step 1. Solve one of the equations for either x or y. We can choose either equation and solve for either variable, but we'll try to make a choice that will keep the work easy. Step 2. Substitute that expression into the other equation. The result is an equation with just one variable, and we know how to solve those. The value of that first variable is found. Step 3. Substitute that value into one of the original equations and solve for the other variable. Let's have an example. Solve the system of linear equations by substitution. The equations are 2x plus y equals 7. This is the first equation. And the second equation is x minus 2y equals 6. Step 1. Let us take equation 1 and solve for y. Let us copy the first equation here. And then solving for y means let us isolate y alone in one side. So the 2x plus y is on the left side. We will transpose the 2x on the other side. If we do that, of course we know that we should change the sign of 2x from positive into negative. So we have now y equals 7 minus 2x. Then step 2, substitute this value of y with respect to x, of course, to equation 2. This is our equation 2. Let us copy that down here. And from step 1, the value of y as 7 minus 2x, we will substitute in here. So we have now x minus 2y, and now the y is changed into 7 minus 2x, and equals, the right side is equal to 6. The negative 2 times 7, also the negative 2 times negative 2x. So on the next step, we have now x, and then this negative 2 times 7 is negative 14. Negative 2 times negative 2x is now positive 4x, equals, the right side is 6. Let us simplify further. This x and 4x can be combined. And the negative 14 we will transpose on the other side, on the right side. So from negative 14, it becomes positive 14. And this x and 4x is now 5x. So we have 5x equals 6 plus 14. And the 6 plus 14 equals 20. Let us continue our solution on this part. So we have 5x equals 20. Let us solve for x. Let us divide the whole equation by the coefficient of x, which is 5. And if we do that, this coefficient of x will be deleted. So we have now x will come down alone, and this is equal to the 20 is divided by 5. And this is equal to 4. Now for step 3, substitute the value of x to any of the original equations. It can be in the first equation or in the second equation, so that we will get the value of y. Let's say we will take the first equation. So 2x plus y equals 7. We will substitute the value of x as 4 in here. So we have 2 times 4 plus y equals 7. This 2 times 4 is 8 plus y equals 7. Let us transpose 8 on the right side. Of course, the sign must be changed. So we have y equals 7 minus 8, and this is equal to negative 1. Let us write our ordered pair. The x is 4 and the y is negative 1. So this is the solution of the system of linear equations. So let us write our answer here, the 4, negative 1. Now let us check if this answer is correct. What we're going to do is to substitute the solution or this ordered pair to both equations and must make those equations as true. So the first equation is 2x plus y equals 7. Let us substitute x to be 4 and y to be negative 1 respectively. So we have now 2 times 4 plus negative 1 equals 7. 2 times 4 is 8 plus negative 1 equals 7. This 8 plus negative 1 equals 7, which is now equal to the right side, then that is 7 also. So the first equation is true when we substitute our answer here. Let's go to the next equation. X minus 2y equals 6. Again, let us substitute the ordered pair to x and y respectively. So we have now x becomes 4 minus 2 times y, and the y becomes negative 1 must be equal to 6. So 4 comes down. This negative 2 times negative 1 is now positive 2 must be equal to 6. And this 4 plus 2 is 6. And we can see that it is equal to the right side value, which is also 6. It means to say our answer here, or the ordered pair, makes both equations true. And this is our final answer. Hi everyone. Today we're going to study system of linear equations, and we're going to solve this by graphing. The graph of a linear equation is a line. Each point on the line is a solution to the equation. For a system of two equations, we will graph two lines. Then we can see all the points that are solutions to each equation. The point of intersection is the solution of the system of linear equations. When we solve a system of two linear equations by graphing, there are three possible cases. Case 1 is intersecting lines, as we can see on the figure. The two graphs intersect in a single point. The coordinates of this point give the only solution of this system. Since the system has a solution, it is consistent. The equations are not equivalent, so they are independent. Case 2 is parallel lines, and our figure here shows parallel lines. There is no solution common to both equations, so the solution set is null and the system is inconsistent. Since the equations are not equivalent, they are independent. Case 3 is the graphs are the same line. And in this figure, we can see one line, but it represents both graphs of both equations. Because we have just one line, there are infinitely many solutions. This type of system is consistent because there is a solution. The equations are equivalent, so they are dependent. Let's have an example. Solve the system by graphing. The first equation is 2x plus y equals 7. The second equation is x minus 2y equals 6. Our step 1 is to graph the first equation. So this first equation we will copy here, and then let us find the intercepts. For y-intercept, we set x equals 0. Thus, the equation 2x plus y equals 7 becomes 2 times 0 plus y equals 7. And we can cancel this 2 times 0. So we can now have y equals 7. This is the value of y when x equals 0. So the ordered pair of y-intercept is 0, 7. For x-intercept, we set y equals 0. Thus, the first equation now becomes 2x plus 0 equals 7. We can ignore the 0 here, so we have 2x equals 7. Let us find the value of x. Let us divide the whole equation by the coefficient of x, which is 2. So we have now x equals 7 over 2. This is the value of x when y equals 0. And let us write the ordered pair of x-intercept as 7 over 2, or we say 3.5, 0. Now, let us draw the line. Let us plot the intercepts. The x-intercept is the point where the line touches the x-axis. So this point 7 over 2, 0 is this point. While the point 0, 7, this is the y-intercept, the point where the line touches the y-axis, and this is the point. And then let us connect these 2 points by a line. So this line here is the graph of the first equation. Now let's go to step 2, and that is to graph the second equation. Let us copy the second equation here, and then let us find the intercepts. For y-intercept, we set x equals 0. Thus, this equation x minus 2y equals 6 now becomes 0 minus 2y equals 6. We can ignore the 0 here, so we have this negative 2y equals 6. Let us find the value of y. Let us divide the whole equation by the coefficient of y, which is negative 2. And if we do that, this negative 2 will be deleted from y. So we have now y equals 6 over negative 2. And when we simplify this, we will get the value negative 3. So the ordered pair for the y-intercept is 0, negative 3. Now for x-intercept, let us set y equals 0. Thus, this second equation, x minus 2y equals 6, now becomes x minus 2 times 0 equals 6. And this 2 times 0 can be cancelled out. So we have now x equals 6. Let us now write the ordered pair for the x-intercept. So we have here 6, 0. Now let us graph the line for the second equation. First, let us plot the 2 points or the intercepts in our rectangular coordinate system. So we have first the x-intercept is 6, 0, and here is the point, and the y-intercept is 0, negative 3, and this is the point. We connect these 2 points by a line, and this line now is the graph of the second equation. So step 3, determine whether the lines intersect, are parallel, or are the same line. In this example, the 2 lines intersect at the point 4, negative 1. And this is the solution. Can you see here? That is the point of intersection, which is 4, negative 1. And this is our final answer. Hi everyone. Today we're going to study system of linear equations, and we're going to solve this by elimination. To solve a system of equations by elimination, we start with both equations in standard form, meaning the x and y variables are on the left side and constant on the right side. And there will be 2 equations. And this is the standard form of a system of linear equations. Now, we will decide which variable will be easier to eliminate. Once we choose the variable to be eliminated, this is what we're going to do. We want to have the coefficients of one variable and that is the variable that we chose to eliminate, to be opposites, so that we can add the equations together and eliminate that variable. This process is what we call elimination by addition. Let us have an example. Solve the system of linear equations by elimination. We have the two equations. The first is 2x plus y equals 7. The second is x minus 2y equals 6. There is a note that if any coefficients are fractions, clear them first by multiplying the equation by LCD, or the least common denominator. But in our example here, there is no fraction. So let us proceed with step 1. Check out which variable is easier to eliminate. We have the variable x respectively for the two equations and the variable y for the two equations respectively. And our goal here is to make the coefficients of the chosen variable to be same but opposites, meaning they are of opposite signs. Let us copy these two equations down here. Let us name them to be first equation and second equation. As for our discussion, I would like to eliminate y for the reason that they are already opposite signs. However, they have different coefficients. So let us do some manipulation. This is the general rule. Multiply the first equation by the numerical coefficient of y in the second equation, and vice versa. It means to say, since I decided to eliminate y, in the first equation, I will multiply the first equation by the coefficient of y in the second, which is 2. And in this case, I will not include the sign. And also, for the second equation, I will multiply this by the coefficient of y in the first equation. And in this case, it is 1. So we have now the first equation to be multiplied by 2 and the second equation to be multiplied by 1. Simplifying the equations, we have this 2 times 2x will be 4x, and 2 times y is 2y, equals 2 times 7 is 14. While the second equation, if we multiply by 1, will just be the same. That is the x minus 2y equals 6. And from here, let us add. Look at our variable y. We have positive 2y and negative 2y that we can simply eliminate or cancel. And then let us add the x and the x. So we have 4x plus x will be 5x. And the right side, this is now equal to 14 plus 6 is 20. Now let us solve for x. Let us divide this equation by the coefficient of x, which is 5. If we divide this equation by 5, the coefficient of x will be 1, which means we can simply copy the x down here, and on the right side, we have 20 divided by 5. And simplifying this, the quotient is 4. So we have a value of x as 4. And then, let's go to step 2, and that is to substitute this value of x to any of the original equations to get the value of y. So we have two equations here. Suppose we choose the first equation. The 2x plus y equals 7. And then let us now substitute the 4 to that x. So we have 2 times 4 plus y equals 7. This 2 times 4 will be 8 plus y equals 7. Let us transpose the number 8 to the right side. The sign must be changed. So this is positive. It becomes negative. So we have now y equals 7 minus 8, and this is equal to negative 1. So y equals negative 1. Let us write the x and the y as an ordered pair. So we have 4, negative 1. And this is the solution of our system of linear equations here. Now let us check if this answer is correct. Let us substitute the solution to both equations and must make those equations as true. Let us take the first equation, 2x plus y equals 7. Let us substitute the 4 into the x and the negative 1 to y. So we have now 2 times 4 plus negative 1 must be equal to 7. 2 times 4 is 8 plus the negative 1 equals 7. 8 plus negative 1 is 7 and equal to the right side, which is 7 also. So the 4 negative 1 makes the first equation true. Let's try the second equation. The x minus 2y equals 6. Let us now substitute the values. So now the x becomes 4 and this y here becomes negative 1. So we have 4 minus 2 times negative 1 must be equal to 6. So this is now 4. This negative 2 times negative 1 will be positive 2 equals 6. And 4 plus 2 is 6 and that is equal to 6. So it is correct. So again, the solution makes the second equation true. It means to say, we are sure that our answer here is correct. And this is our final answer. I hope you learned something from this video. See you again next time.